According to the National Electrical Code, specifically Section 334.15 COM, where non-metallic sheathed cable, commonly known as Romex, passes through metal studs or joists, it must be protected. This protection comes in the form of a sleeve, bushing, or similar approved method. The code emphasizes the necessity of preventing damage to the cable's outer jacket, which could lead to electrical hazards. To meet this requirement, insulating bushings are used. These bushings are specifically designed for use with metal studs, typically made of plastic or rubber, offering insulation and a smooth surface for the cable to pass through. The primary function is to prevent the cable from coming into direct contact with the sharp edges of the metal stud, reducing the risk of abrasion or cuts to the cable sheathing. When installing Romex through metal studs, there are several important aspects to take into account. Firstly, the size of the holes drilled in the metal studs must be adequate. The hole should be large enough to accommodate both the insulating bushing and the non-metallic sheath cable without causing any pinching or crimping of the cable. A tight fit can damage the cable over time, increasing the chance of electrical faults. Secondly, the tightness of the bushings is crucial. Once installed, bushings should be securely tightened around the cable. This prevents movement and ensures proper, continuous protection. Loose bushings can slide, exposing the cable to the sharp edges of the metal stud, defeating their purpose. Thirdly, attention needs to be paid to sharp edges. Before installing the non-metallic sheath cable and bushings, remove any sharp edges or burrs from the metal studs. These imperfections can damage the cable even with the bushing in place. A file or deburring tool can be used to smooth the edges of the holes. Fourthly, cable support is vital. If the non-metallic sheath cable runs horizontally through metal studs, provide additional support using cable straps or other approved means. This prevents sagging of the cable, reducing stress on the cable and its connections. Sagging can occur due to the weight of the cable, especially over longer spans, potentially leading to insulation damage or connection failures. Fifthly, consider firestopping. If the metal studs are part of a fire-rated assembly, ensure that the bushings used are compatible with the required fire-stopping materials. Fire-stopping materials are used to seal openings in fire-rated walls and floors, preventing the spread of fire and smoke. The bushings must not compromise the effectiveness of these materials. Lastly, labeling is a key consideration. Use labeled non-metallic sheath cable that meets the National Electrical Code requirements for use in metal studs. This ensures that the cable is suitable for the intended application and complies with safety standards. Proper labeling provides assurance of the cable's quality and suitability. To further expand on the selection and installation of insulating bushings, it is important to understand the types available. Common types include snap-in bushings, which are easy to install by simply snapping them into the hole in the metal stud, and clamp-on bushings, which provide a more secure fit by clamping onto the cable. The choice depends on the specific installation requirements and the size of the cable being used. When selecting a bushing, ensure it is listed and labeled for its intended use. This listing ensures it has been tested and meets industry standards for safety and performance. The National Electrical Code requires that all electrical components be listed by a recognized testing laboratory. Furthermore, inspect the bushings for any signs of damage before installation. Cracks, breaks, or other defects can compromise their ability to protect the cable. Damaged bushings should be discarded and replaced with new ones. The process of installing non-metallic sheathed cable through metal studs involves several steps. Firstly, measure and mark the locations where the cable will pass through the studs. Use a drill bit size appropriately for the cable and bushing combination. Ensure the hole is centered in the stud to maintain structural integrity. Secondly, after drilling the holes, deburr the edges to remove any sharp metal fragments. This step is crucial for preventing damage to the cable. Thirdly, insert the insulating bushing into the hole. Ensure it fits snugly and is securely in place. For snap-in bushings, apply firm pressure until they click into position. For clamp-on bushings, tighten the clamp screws until the bushing is secure. Fourthly, carefully feed the non-metallic sheath cable through the bushing. Avoid pulling or yanking the cable, as this can damage the insulation. Maintain a smooth and steady motion. Fifthly, once the cable is through the bushing, inspect it to ensure it is not pinched or crimped. The cable should move freely within the bushing. Sixthly, secure the cable to the studs using cable straps or other approved supports. These supports should be installed at intervals specified by the National Electrical Code, typically every 4.5 feet horizontally and 12 inches from any boxes or terminations. In addition to these steps, consider the routing of the cable. Avoid running the cable in areas where it could be subject to physical damage. Keep the cable away from sources of heat or moisture. If the cable must pass through areas where it is exposed to physical damage, provide additional protection such as conduit. When multiple cables are run through the same stud, maintain adequate spacing between them. This prevents overheating and ensures proper ventilation. The National Electrical Code specifies the maximum number of cables that can be run through a single hole in a metal stud. Consult the code for specific requirements. Grounding is another critical aspect to consider. Ensure that the grounding conductor within the non-metallic sheathed cable is properly connected to the grounding system. This provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding conductor should be securely connected to all metal boxes and enclosures. Proper grounding is essential for electrical safety. Also, be mindful of the ampacity of the non-metallic sheathed cable. The ampacity is the maximum amount of current the cable can safely carry. Select a cable with an ampacity that is appropriate for the circuit it will be serving. The National Electrical Code provides tables that specify the ampacity of different sizes of non-metallic sheathed cable. Do not exceed the cable's ampacity, as this can lead to overheating and fire. Furthermore, consider voltage drop. Voltage drop is a decrease in voltage that occurs along the length of a conductor. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. To minimize voltage drop, use a larger size cable or shorten the length of the run. The National Electrical Code provides guidelines for calculating voltage drop. It is also important to protect the cable from physical damage during construction. Avoid stepping on or dropping heavy objects on the cable. If the cable is exposed to sunlight, use a cable that is sunlight resistant. Sunlight can degrade the cable's insulation over time. Consider using a cable with a UV resistant jacket. When working with electrical systems, always follow safe work practices. De-energize the circuit before working on it. Use insulated tools. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous if not done properly. When using metal studs, it's important to ensure they are properly grounded as well. Connect the metal studs to the building's grounding system to prevent them from becoming energized in the event of a fault. Use grounding clips or screws to make the connection. The grounding system should be inspected regularly to ensure it is functioning properly. Metal studs can conduct electricity, so it's essential to take precautions to prevent electrical shock. When running cable through walls, consider the placement of other utilities such as plumbing and HVAC. Avoid running the cable in areas where it could be damaged by these utilities. Maintain adequate clearance between the cable and other utilities. The National Electrical Code specifies the minimum clearance requirements. Also, be aware of local building codes and regulations. These codes may have additional requirements for electrical installations. Consult with the local building department to ensure compliance. Building codes are designed to protect the health and safety of the public. When installing non-metallic sheathed cable in metal studs, it is important to follow all applicable codes and regulations. This will ensure a safe and compliant installation. Failure to comply with codes and regulations can result in fines, delays, and potentially dangerous conditions. If the non-metallic sheathed cable is run in an exposed location, such as a basement or garage, it must be protected from physical damage. Use conduit or other approved means to protect the cable. Exposed cable is more susceptible to damage from impact or abrasion. The National Electrical Code specifies the types of protection that are required for exposed cable. When installing non-metallic sheathed cable in a damp or wet location, use a cable that is rated for wet locations. This cable has a moisture-resistant jacket that prevents water from entering the cable. Do not use standard non-metallic sheathed cable in wet locations, as this can lead to electrical shock. The National Electrical Code specifies the types of cable that are permitted for use in wet locations. Also, when running non-metallic sheathed cable through thermal insulation, the ampacity of the cable must be directed. Thermal insulation can trap heat around the cable, causing it to overheat. The National Electrical Code provides tables that specify the directing factors for different types of insulation. It is important to direct the cable to prevent overheating and fire. Remember, electrical work should only be performed by qualified individuals. If you are not familiar with electrical codes and safe work practices, hire a licensed electrician. Electrical work can be dangerous, and mistakes can lead to serious injury or death. When making connections to electrical devices, such as outlets and switches, use approved connectors. These connectors are designed to provide a secure and reliable connection. Do not use wire nuts or other makeshift connectors, as these can be unreliable and potentially dangerous. A National Electrical Code specifies the types of connectors that are permitted for use in electrical installations. When working with non-metallic sheathed cable, it is important to use the proper tools. Use a cable stripper to remove the outer jacket of the cable without damaging the insulation on the individual conductors. Use a wire cutter to cut the conductors to the proper length. Use a crimping tool to crimp connectors onto the conductors. Using the proper tools will ensure a safe and professional installation. Before energizing a circuit, always test it to ensure that it is properly wired. Use a multimeter to check for voltage, continuity, and ground faults. This will help to identify any potential problems before they can cause harm. Testing is an essential part of electrical safety. When working with metal studs, be aware of the potential for corrosion. Metal studs can corrode over time, especially in damp or humid environments. Protect the studs from corrosion by applying a protective coating. Inspect the studs regularly for signs of corrosion and replace them if necessary. Corrosion can weaken the studs and compromise their structural integrity. Also, consider the acoustic properties of metal studs. Metal studs can transmit sound, which can be a problem in some applications. To reduce sound transmission, use sound dampening materials, such as insulation or resilient channels. The acoustic properties of metal studs should be considered during the design phase. When installing non-metallic sheathed cable and metal studs, it is important to plan the installation carefully. Consider the layout of the building, the location of electrical devices, and the routing of other utilities. A well-planned installation will be safer, more efficient, and more cost-effective. It is also important to document installation. Keep a record of the location of the cable, the type of cable used, and the date of installation. This information can be helpful for future maintenance and repairs. Documentation is an essential part of good electrical practice. And as a final reminder, always prioritize safety when working with electricity. To energize the circuit before working on it, use insulated tools and wear appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical safety should be the top priority.